feels a lot better. But these guys are not. Holy shit. These guys are not anything that, so I'm confused.
So you're telling me I actually have to participate?
Like all 4 of these are gone.
I know.
Welcome to class, everybody.
I'm Mr. Denton.
Oh, it's nice to meet you.
Yeah, yeah. Alrighty, so we are going to continue on. Now, I'm not sure, I'm guessing I haven't been abundantly clear. We are going to review for 2 more days. So today is questions 41 through 60 off the final. So there is the front, and here is the back. And if you want to go and pause that and look at that, that's fine. Remind yourself that you get a double-sided 3x5 for the final. It is going to be for you guys next Tuesday. So it is what it is. Now there's only 1, 2, 3, 4, 5, 6. Holy nuggets, 8. So we probably won't go to 9. Probably never get up to 9.
I mean, unless you want to.
Yeah, I guess unless I want to, but alrighty. So it is 5:12 today. This is 7th period, and this is going to be Chem. 11:10. Cumulative review, day 3. Alright, so we'll need lots of participation from those of you that are here. So, first thing I've written down is dilution by adding H2O. Does anyone remember how we did dilution problems? I've actually mentioned this once before during this review, I believe. So it was a really standard equation we used.
Oh.
Nobody? Yeah, it's M1V1, right?
Oh.
So I'm going to do M1V1 equals M2V2, right? So we're going to go crazy handy. And we'll start out small. Let's go for 3. Okay, let's go for 3. So here's the question. It says, what will the molarity be of 27.6 milliliters of 1.4 molar HCl solution if I add 31.4 milliliters of H2O to it? Okay. So, it's a standard M1V1 question. To me, this is straight up plug and chug, right?
Yeah.
There's 4 variables. They give me 3 of them, if you will, and they expect me to find the 4th, but make sure you pay attention to how this is worded. So 3 hands. One. I don't think I've ever done only 3.
Oh, we're
2.
We're kind of low on numbers.
Yeah. 3. Alrighty. So, Alden.
Yeah.
So if I go back to my M1V1 equation, what is going to be M1 and V1?
M1 is 1.4.
So 1.4 molar times V1 is
27.6.
27.6 milliliters equals, what is M2?
You don't know.
You don't know. That's what you're finding, M2. Now here's my question. What is V2?
59.
59.0 milliliters. This is really, really important. Because what did I do? I added water, which means my volume had to go where? Up, right? Now, because I know how this works, who can remember what kind of relationship these have? Direct?
It's an inverse.
Inverse, right? So when I'm done, what do I know my molarity 2 has to be?
Lower.
It has to be lower because I'm diluting it. I'm making it less concentrated. When I get done, if my M2 isn't lower than my M1, what do I know? I did something wrong. So what'd you get for M2 here?
0.65.
0.65 big M. Did anybody else get 0.65 big M?
Yeah.
Yeah? All right. Okay. All righty. Next thing I wrote down was this. Lowest Ka equals the weakest acid. Now, anybody in here remember what Ka stood for?
It's a.
Oh, yeah, you should probably remember
I
this.
just reviewed it last night. and I
Yeah,
just
did
totally
you?
forgot.
I didn't get that till I was laying in
Oh
bed.
yeah, that's fine. He was
Sorry.
He was just wondering. He had no timeline really.
Oh, okay. Because that video does a really good job.
Okay.
Have him watch that. Who was it?
My cousin David McConkey, he goes to Westlake.
Oh, he's a
taking lot of
Thunder.
attention. Yeah.
What class is he in?
Chem 1110.
Oh. Yeah, me just doing the problem I didn't think would,
Yeah.
but watching it I thought would be better.
Uh,
So basically I'm helping a kid from Westlake. Is that what you're telling me?
Yep. Yeah. I gave
Alrighty.
him your YouTube.
What?
As well. I gave him your YouTube as well.
Oh, that's
He doesn't
No, that's-
understand his teaching.
that's a.
also.
I'm telling you, kids that watch it do well. I told you about that mother, right? Yeah, I mean that's. Nobody in here remembers what Ka was. Nobody. It was the dissociation constant.
Yeah.
Okay.
'Cause, like, in order to find your pKa.
Yeah. Okay. We used it for pKa. We did that, right? But what the way they're going to use it is this. Is the Ka tells me how much that acid splits apart, right? And what we did is we said that if I have a Ka that's high, that is a strong acid. Because by definition, a strong acid was an acid that completely dissociates, right? Well, if I have a Ka that is low, that is a weak acid. Well, the lower it is, the
Less it dissociates.
which makes it a weaker acid. The higher it is, the stronger it is. The lower it is, the weaker it is. So if they give you a list and say which of these is the weakest, it's the one with the smallest Ka. If it says which one is the strongest, it's the one with the highest Ka.
So will we have to do the pKa?
Have I covered the pKa?
Not quite.
I mean, we got today and tomorrow, so there's still a chance. So you're telling me there's a chance? Nobody?
What's that from?
Dumb and Dumber.
That's what it
She
is.
says you got like a 1 in a million, and he goes, so you're saying there's a chance?
Doesn't he get
Such
it by
a
the
good
end of the movie?
No, he.
First one is better than the second one, though.
Yeah, the first one was. I mean, you'd have to, when it came out, it was like the Napoleon Dynamite of its time. It was a cult classic instantly. Yeah, so it was funny. I mean, Alrighty, now from there, along those same lines, we need to know pH calculations. Okay, which again is number 2 from last night. Yeah, see how I'm looking at you. Now, if I give you this H3O positive of 1.4 times 10 to the negative 4th, could you calculate the pH?
Yes.
Okay, what do you do? Anybody remember how to calculate pH? I know it's been a long time.
I have it right here.
Isn't it just the pKa or plus the log of,
Okay, that's if I'm finding the,
So the negative log.
that's a pK. If I want just the pH, it is just the negative log of H3O positive. But what do I know it's going to be really close to? Without doing any math. No,
Or,
it's going to be close to 4.
oh yeah.
Oh, yeah.
Yeah.
Right? You guys remember me teaching that now?
Yeah.
So I do the math, and what do I get?
.85.
3.85. 3.85. Now, what if I ask for this? What if I ask for the POH?
Then it would be
Oh,
14 minus 6.
So
Yeah,
10
14 minus the pH, which is going to be what?
10.15.
14 minus 3.85, which is 10.15, right? Now, if you recall, let's say I did this. Let's say I said, find the pH of a, let me see what I did here, of a solution with a OH negative concentration equal to 4.4 times 10 to the negative 9th molar. Now, what is wrong with a problem like that? Anybody know? Or I should say, what is wrong with that problem? Anybody remember?
doesn't give you your H3O.
Doesn't give me my H3Os, right? pH does not go with OH negative, does it?
No, it goes with.
No, but how did we do that?
You just find the POH.
I'm going to find the POH from that
14.
and then subtract that from 14. That's one way. Anybody remember the other way?
We have it's like H3O positive concentration.
Yeah, that's the,
OH negative concentration.
but that was the KW.
Oh, yeah.
KW is the H3O positive times the OH negative, which is 1.0 times 10 to the negative 14. That's that way as well. Either way can be done. Let's do this. Let's try this right here. Find the pH of a solution with this. I'm giving you that, but I want pH.
And does it matter which way we do it?
I don't care how you do it. Either way works. So let's go with 4 hands. We'll go with 4 hands and can find the pH. One, two, three. One more. Four. Alrighty, so which one of you 4 want to take a stab at this? Go for it, Evans.
So I just did the negative log of.
So you found the POH, right?
Yeah.
So POH is the negative log of 4.4 times 10 to the negative 9th, right?
Yeah.
That gave me what?
That gives you 8.35.
8.35? 8.36?
Yeah, 8.36.
8.36, okay.
And then you just take 14, subtract.
pH then is 14 minus 8.36, and that gave me what? 5.64. Anybody else get that? Did you guys get that? Okay. There'll be a pH, at least one pH. There's probably going to be more, but so far there's been that one. Okay. Alrighty. So next thing is half-life. Okay, we're going to go raisey-handy again here. Let's go half-life. Going to go for 5 hands. Okay. So given a 72-gram sample of a radioactive isotope with a half-life of 72 days. Check that. Backwards. That's backwards. It is 27 days. Half-life of 27 days. How much? How much will be left after 81 days? Okay. So, given a 72-gram sample of a radioactive isotope with a half-life of 27 days, how much will be left after 81 days? Okay, I taught you. I taught this the stupid way, right?
Yeah.
I mean, right? Wasn't that the? I mean, I hated it, but that's the way it is. So I have 1 already. So I got 1. Got to have 5. So that's all but 3 of you. So some of you might need to participate. Two, 3. Four. 1 more. 5. All righty. So, Chance, you want to take a stab at this?
You want me to say the answer?
Yeah, well, give me the answer and then let's go through it.
I got 9 grams.
You got 9 grams. Anybody else get 9 grams?
Yeah.
Okay. Now, in reality, it would probably really be what? It probably should be 9.0 grams. Why? Yeah, each one of these have 2 sig figs in them, right? Does that make sense?
Yeah.
But yeah, I don't know. I would imagine that sig figs are going to raise their head a little bit, but I do not think it will cost you an answer. Anyway, I haven't noticed that because mathematically, I think there's only about 10 or 12 actual calculations on the test. Most of these questions you're literally going to be able to look at and you're either going to know the answer or you're going to think to yourself, I should have studied harder. That's it. That's the only, that's it. Okay? So what'd you do?
So what I did first is I did 81 divided by 27.
Okay.
3.
And that 3 is the number of what?
That's the number of half-lives.
3 half-lives. So he's went through 3 half-lives, right?
Yeah.
So then what'd you do?
And then I did, to divide, so I started 72 divided by 2, but then I did 2 to the third.
Okay, so you did it that way, and that's fine. He just went 72 over 2 to the third, right? Which gives me my 9.0 grams, right? Now, when I taught it, we taught this like 3 different ways, right? I could take 72 and divide it by 2, and then take its answer and divide it by 2, and take its answer and divide it by 2, right? Or I could have taken 72 and times it by what? 1/2 to the 3rd power. Ultimately, we're all doing the same thing, and you're going to come out with 9 grams. Good job, Chance. Okay, does that ring a bell? All righty, so, alpha decay. Now, I'm going to be honest. I'm not 100% sure why all I wrote was alpha decay. Okay, I'm sure, though, what I'm talking about is what? Yeah, I'm talking about radiation here. Radiation here. Probably the decay portion is to remind me that it's a what? When they use the word decay, whatever they're talking about, is it a reactant or a product? Product. What do they use if it's a reactant? Bombardment or something like that, right? So, let's say I gave you this. Let's say I start out with U235 and 92, and I'm going to go through 2 alpha decay. 2 alpha decay, okay? Plus, there's going to be something else left there. What is going to go in that blank? And we might as well go with 6 hands. Pretty soon we'll be just at 8, and we'll stay at 8 because there's no ghosts in here. Okay, I need to know what goes in that blank. Now, while you're doing that, can anybody remember where everyone's made mistakes on a problem like this? Yeah, they forget to multiply that 2 in, right? Don't forget the 2. I have 1, 2, 3, 4, 5, 1 more. 6, alrighty. Pretty much everybody's participated, so does anybody want to just take it?
I can.
Go for it, Peyton.
I have radium 227 and
227, 88, is he right?
Yeah.
Yeah. Just don't forget, that's an 8, that's a 4, make the math work, right? Okay? Not overly complicated there. Alrighty, now, I did the same thing with this next one. All I wrote down was aldehydes. Okay, now probably it's not about aldehydes, but who remembers what that was about? When I use the term aldehyde, who remembers?
Your function group.
What?
Your functional group.
Okay, we're talking functional groups. Okay, what else? Nobody remembers the 3 tables?
Oh,
I told you to remember, right? Yes, we had the carbonyl groups, right? And then we had the
hydrox, that one?
well, yeah, but then what was the other table?
the heteroatom.
Yeah, there was heteroatoms was the first table. That was when I had like halogens and things like that. The thiol, right? And then I had the carbonyls. And then what was the last one? I don't remember. But you know the 3 tables I'm talking about?
Yeah.
So what I'm thinking is just remember the functional groups. Now, obviously, they're not going to ask 12 questions. I think there were 12 total things on those charts, right? We're talking maybe like the ketones. We had the esters, the ethers, the carboxylic acids. I would, make sure, but I would for sure know what that one was. There's probably a reason I wrote down the aldehydes. But I know it's because there's a question about functional groups on there. Okay?
Do you
And
remember what page the tables were on in the textbook? Was it-
40, I can see Gloria's probably got it.
I think it's 403 and 40. 402 through 403 and 405, I believe.
I just have the chart if you want to take a picture of it.
That could work.
What do you know when that was?
It was chapter 11.
Chapter 11. So I'm
Pages
guessing.
402, 403, and 405.
Bam, there you go.
So he had it.
He had it almost. Yeah, good job. I did say them a lot that chapter though. Okay. All right, so yeah, just make sure of that. Now, let's name something. Okay. I want everybody to name this. Okay, so we're going to name that. And I believe that would put us at 7. One, 2, 3, 4, 5. Am I going to get 2 more? Negative? Well, let's get going here. We're going to run out of time. All right, so who wants to take this? Anybody? Anybody? Nobody? You got a McConkey? What do you got for me?
Zig, zag, zig. Oh,
I already,
sorry.
I already drew it, big guy.
Yeah, got that. I did 4 ethyl dash, so 4 dash ethyl dash 5 dash methyl dash 2 dash heptane. Heptene, sorry.
Heptene. Is he right?
Yeah.
Yeah. Now, I'm going to be honest. Okay? I'm not sure I would have even got that far. Anybody know what I mean when I say that? Check that. I shouldn't say got that far. I don't know that I would have went that far. Anybody know why? Anybody think they know how Mr. Denton thinks? That's good, because it's not very well. Okay? What I would have done is this, is I knew a couple of things about this already, right? I knew it had 2 branches. Okay, but more importantly, I knew it was an ene. I looked through the answers. I'll bet you I can get rid of one of those, because I'll bet one of those is an ane. I've thrown it out, right? Well, I know that because double bonds do what? Double bonds rule, right? Yeah. Because double bonds rule, I know it's got to be a 2-heptene. I could probably get rid of one more right there. I've narrowed this down to a 50-50 question. Do you know what I'm saying? Yeah, I would have went 1, 2, 3, 4, 5, 6, 7. Off my 4th, I've got an ethyl. It comes first because it's alphabetized, right? Dash 5 dash methyl because of my methyl group, dash 2 dash heptene. But do you see how I can, if I'm not 100% sure, because it's multiple choice, do you see how I can kind of whittle that away? You're welcome, by the way. Okay? Does that make sense? Yeah? All right, let's go again. Let's go with this. Now, this is what I'm going to do. I'm going to give you a name, and I need all 3 forms. I need what? Skeletal, complete, and condensed. So this is what you got. We're going to go 3-ethyl dash 3-octene. 3-ethyl-3-octene. And let's go four hands. And I'm going to see if my arm is strong enough to take the roll. While you guys are working on that. There are 16 kids absent.
Oh, dude, that's crazy.
That is nuts. I have one. Yeah. Oh, so
Yeah.
2. That's just insane.
I mean, the classes here.
Alrighty, so 3 and 4. Get one more of you. Five, there we go. Alrighty, so who wants skeleton? Alan, what do you got?
Zigzag, 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 zig.
Okay.
And then on the third one, you have one going down, or 2 going down, sorry.
Like that?
Yeah.
Okay.
And then that one's also bonded to the one going right.
So double bond like that.
Yeah.
Is you right?
Yeah.
Okay, so that's my skeleton, right? Okay, from there, where would be the next logical place to go? I'd say complete, definitely. Who wants to see me? Okay.
So CH3.
Oh, so you're going CH3 like this?
Oh, no, so zigzag.
No, let's go do it with C's.
Yeah.
So I got a C and a C.
Okay. See, I just drew it on like the.
Oh, gotcha. So you went up here and did it. Okay, gotcha.
So C, and then and then double bonded to C, and then single bonded to another C, to another C, to another C, to another C.
That sounds like my GPA.
And then on the third one, right before the double bond, I drew a line down and did C. And then another line down to
And then obviously just a buttload of H's, right? Except for right here, does that have any H's?
No.
No. This one has one though, right?
Yeah.
Like that, correct? I ain't drawing those H's in, sorry. Okay, so we're there. Then I gotta go condensed. Anybody want condensed?
I can do it.
Okay, Evans, what do you got?
I got CH3, CH2, then a C, and then a double bond, and then a CH, CH2, 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 and then a CH3. And then off of your single C, right before the double bond, I have a line going down, and then a CH2 and a CH3.
Just like that. What if I asked you what kind of carbon that was right there?
It's a quaternary.
Quaternary. Tertiary?
Yeah, because there's double bonds, but there's no extra C's. There's only 3
There's
C's.
4 carbon-to-carbon bonds, though.
It's 4 because it's carbon to carbon bonds. It's a double bond, so it counts as 2.
Oh, okay.
Okay? Does that make sense? Okay. This one would be a 3 degree because there's still one H there, right? So yeah. Okay. Alrighty. Now what I wrote down next, this is all I wrote down. I wrote down valid IUPAC names. Now this goes back to chapter 12. Does anybody remember how I suggested you answer questions like this, where they simply say, is this a valid IUPAC name, Alden?
If it's like higher than propyl or propane, then it will probably be the main.
If the branch is higher than propyl, it's probably not a branch anymore. It's probably part of the main chain, right? Okay, that was one way. What was another way?
Check if it's alphabetized.
Check if it's alphabetized. If all those things work out, though, what do I do?
Just draw it and rename it.
Draw it and rename it. Draw it and rename it. Because I think we're pretty good at naming things. And if your name and their name don't match, it's probably invalid. But I would definitely do those other 2 things first. Alphabetization and look for branches. Branches, butane or bigger, it's probably not a branch anymore. Okay, but yeah, draw it and rename it if you can't find an obvious screw up. Does that make sense? Yeah? Alrighty. If I use the term unsaturated, anybody know what that means?
It doesn't have a complete amount of bonds.
Well,
It's like an oil,
it's an
right?
alkene or an
Okay, so it's like it is an oil.
It's liquid.
Yeah,
It's a liquid, right?
alkene or an alkyne, right?
It is an alkene or an alkyne, but what does all those things really mean?
Oh,
It doesn't have as many hydrogens.
Okay, well, if it doesn't have as many hydrogens, that means what?
it has. a
Say it louder.
Double bond or triple bond?
Double bond or triple bond. So it must have at least 1. So unsaturated simply means it must have at least 1 double bond. Now, it could be triple. Typically, from what we saw, they were doubles, but it could be a triple as well. But it's got to have just 1. Then it's unsaturated. If it's saturated, that means it has all single bonds. Okay? Alrighty. Now, in this vein, and we haven't thought about things this way, but if I say something has a low melting point, what does that mean? There's 3 ways you could look at this. But if I'm thinking about this way, does anybody know what it means to have a low melting point?
A lot of branches.
Okay, so one way was to look at the branch. If it's got a lot of branches, it makes it more spherical. It's got a low boiling point, right? Or a same thing, low melting point, right? What was the other thing?
Less carbon.
Less carbons, right? Smaller chain has a lower melting point, right? But if I'm thinking about it this way,
It's unsaturated.
okay, which means it's going to have the what?
A double bond.
Double bond.
But if it gave me like 4 things, it would be the one with the what?
Most amount of.
Most double bonds. And if I say, and really for any of these, it would also be true if it was the most amount of what? Triple bonds. But I'm going to be honest. Have we done a triple bond? I think there's only been like 1 triple bond question that they've asked. And I want to say it was on the last test. Anybody remember the question they asked? It looked like this.
Oh, yeah.
Anybody remember this question?
Yeah.
It wasn't even about this. It simply asked, is this possible?
No.
No. Why? Because it's got 5 bonds. This is not possible. And I believe, I'm pretty sure that was the answer on one of the questions on the last test. Something about this. Because I remember the drawing looking something like this.
I remember you drew something like that a long time ago.
Did I? Well, I know that there was a test we took that had a question similar to this on it. Okay?
So will they, I guess you said they probably won't have triple bonds, but like if they did, would they mix the double and triple bonds?
They could, but we haven't. Yeah, I would not. I don't know, other than, like I said, something like this, where they're not really asking you, they're really asking you about the number of bonds carbon can make. They're not going to ask you, I have not seen an alkyne question yet.
Okay, so they wouldn't ask you though, like, compare like a triple bond to a
No,
double bond?
no. Consider anytime it's a multiple bond.
Okay.
Yeah, group them together.
Okay.
Yeah, I do not. Up to 60, there's not one. My guess is there's not one at all.
Okay.
Yes.
So in naming alkynes, would you just?
Exact same rules
But
as alkenes.
It's not.
Yeah, just an ein.
Okay.
Everything else, the exact same. That's a great question. But again, some things had to get cut. That was one of them. So, rules apply, same thing. I mean, I guess they could. Like I said, I got 20 questions left. If that changes, I will let you know. Okay? Alrighty, if I use the term aromatic, you need to immediately think what? Okay, now, not just a benzene. If I wanted to think bigger, as in more general, cyclo. Any kind of cycle. Benzenes qualify. But anything that is cyclical falls under the aromatic concept. So they said, which of the following is an aromatic? And then we're going to look down that chart and say which one is a cyclical structure. Could it be a benzene? Yes. Does it have to be a benzene? No, but it is cyclical. Okay? Alrighty, then from there, Markovnikovs. We use Markovnikovs in 2 different places. Markovnikov's rule, where does it apply? It is, that's the rule, but where? It applied in 2 places in this chapter.
Hydrohalogenation
It applies in hydrohalogenation
and just hydration, right?
and just hydration, right? Okay, just hydration. So in hydrohalogenation, what 2 did we use? Does anybody remember? What the 2 I'm pretty sure I said there were 2.
HCl and BR.
HCl and HBr. Okay, what was hydration?
H2O.
H2O.
And Fe, was it? It's not that.
No, that's chlorination of benzene is the FeCl3. That was from last time.
The H2SO4.
The H2SO4. H2O and H2SO4 as a catalyst, right? Now, the reason Markovnikov's rule applies to these 2 and not the other 2 is that these are different. I get an H and a Br, or I get an H and a Cl, right? Here, H2O, I get a what? An H and an OH, right? Now, what is important to remember about hydration? There was something else hydration always gave me.
An alcohol.
Gave me an alcohol. Yields an alcohol. Because I have that hydroxy, that OH group on it, right? Which now allows it the hydrogen bond and dipole and all those other things, right? So, if I look at this, here's my molecule. Okay, and let's say I've got this, right? So, here we go. I've got every one of these represents a carbon, correct? I'm going to add HBr to this. I know my double bond's going to break, right? Half of it's going to go here. The other half is going to go there, right? Which is going to go at each spot.
H on the right,
The H is over here. Why?
because it has more H's than the one on the left.
Right? Before I drew these two lines in, how many H's did the right carbon have? 1. How many H's did the left carbon have? 0, right? So it had 1, it gets 1. Well, if the H goes there, the Br must go there. Double bond is now gone.
Do you remember the catalyst for this one?
That's a good question. Anybody remember what I taught you right here?
Palladium.
No. When we hydrated something, we needed a strong acid, right?
Yeah.
Well, what do you notice about those two?
Strong acid.
They're already strong acids, so they
No catalyst.
did not need a catalyst. Exactly. Hydrogenation, hydration, and what was the third one that needed a catalyst? There are 3. You're right. Chlorination. But that's different because that was chlorination of, specifically chlorination of benzene, where I needed 2 of them and I simply replaced an H with the chlorine. Yeah. Does that make sense? And I am pretty sure that there is one of everything on the test. There's one of all 5 of those, technically. So I've got the 4 where the double bond breaks and I add them in on each side, right? With the halogenation, the hydrohalogenation, the hydrogenation, and the what did I miss?
Hydration.
Hydration. I don't remember, but those 4. And then the chlorination of benzene was the one that behaved like last chapter, where the Cl simply replaces one of the H's, the double bonds don't break. Because that's unique to benzene. I would say those 5, there's going to be at least one question on each. So make sure I know what it is, what catalyst, if any, are needed, and what I get out. Okay? That's it. That's all I got. Okay? Now, a couple of things to remember is next time is it. So that's Friday, right?
Yeah.
If there's something you go back through these you don't understand, that would be a great time to ask. Okay, there will be about half and half because we have 20 questions left and we have about 10 of them are going to be cumulative questions, 10 of them are going to be 13 specific questions. But, 13 specific, 13 specific, 13 specific. About half of today's been 13 specific as well, so, it'll just know how to name things. You know what I mean? Okay? Questions? Nothing? Okay. Hope you guys make better use of the time I give you than my last class did. They sucked. They just, I don't know, they just sit there and did nothing. Talked a little bit. I shouldn't say all of them. I had a couple of kids just flat getting after it. Hannah Bruce is a machine when it comes to that kind of stuff. You guys know Hannah. There's a few boys, though, that I swear they just twiddle their thumbs.